Hi, my name is Mike Strusz, and in this presentation, I'm going to take 10 pieces of data from a store called Urban Wares, which is an upscale clothing and accessory brand, and make meaning out of the data set. I first broke the data set down into which measures were numerical and which were categorical. In the numerical category, I broke it down into discrete and continuous. A discrete variable would be the income given in thousands. And a continuous numerical data would be distance traveled, while all people reported their distance traveled in miles and whole numbers. They hypothetically could have given any exact distance along a decimal amount. The rest of the variables were categorical. Uh, this first group are all nominal, and that's they differ in name or category only and have no particular rank. First would be their occupation, whether they own a smartphone, yes or no, whether they subscribe to the newsletter, yes or no, whether they were satisfied was presented as true or false, and the date. One ordinal piece of data was their education level, because you can rank uh, one's education. I found another helpful way to break down the data was some of the pieces of data were the type of customer, such as the age, the education level, the income, and their occupation. The rest of the data talked more towards the customer engagement, with distance traveled being one, subscription to the newsletter, customer satisfaction, whether or not they have a smartphone, and their date of purchase being more towards customer engagement. So let's take a closer look at those type of customer data pieces. Age of the customer, you can see a histogram here on the right side of your screen. You can see that more of the ages fell on the left side of the graph. Of this distribution, the mean was 34.8 years old. The median was a 34-year-old. Since this is not a normal distribution, potentially looking at the middle 50% would be helpful. Uh, the median of the lower half of the data was a 29-year-old. The median of the upper half of the data was a 40-year-old. So 50% of the customers are in that age range, which would be a spread of 11 years. As far as measures of position, a 36-year-old in this data set would be in the 60th percentile, meaning that 60% of these customers would be 36 years old or younger. This data set is negatively skewed with a larger amount of customers on the younger end and a longer tail towards the older customers. There's no mild or extreme outliers. I found that by doing 1.5 times the interquartile range, which would be 16.5. I then added and subtracted that from the upper and lower ends of the interquartile range and found no customers were older than 56.5 or younger than 12.5 years old. Next, let's take a look at their education level. 80%, these last three bars would tell us that 80% are college educated, with only 2 of the 10 customers being high school grad only. 50% have advanced degrees, 3 of them with a master's and 2 with a PhD. With those advanced degrees, we might expect a higher level of income. 50% of the customers had an income between 45 and 60,000. 30% had incomes of 60 to 75,000, and 20% had a income of 75 to 90,000. The mean or average customer has an income of 63.8 thousand. The standard deviation of this data set is 14.18K, and the median customer made 62.5 thousand. The Q1 and Q3 numbers are 49,000 and 77.5 thousand. So that's where the middle 50% would lie. Next, let's take a look at customer occupations. With those advanced degrees, you can see in this list a lot of professional customers. If we combine this with their age, education, and income, we can paint the picture of a typical customer who is a middle-class, college-educated professional in the first half of their career. Let's look at the pieces of data that dealt more with customer engagement. Here's a dot plot of distance and income, with income being on the x-axis and distance traveled on the y-axis. You'll note that the correlation, or R variable, is negative 0.45, which would suggest a mild negative correlation. We have some numbers up here that aren't quite mild or extreme outliers, but maybe make this correlation weaker. I did test what it would do if I removed this person who traveled 40 miles, and removing that data piece alone strengthened it to a negative 0.57. This could be a classic correlation does not equal causation example. A potential confounding variable might be that these top earners who didn't have to travel as far to the store might live in the nicer part of town that's closer to this shopping center. And some of the lower income earners might live on the not as nice half of town that's even further from the shopping center. I wouldn't suggest that living closer to the shopping center is making anyone richer. But if you were wondering if this store was in a good position to attract high-paying customers, this chart would suggest that your more higher-paying customers are traveling fewer miles to the store. Of the three people who traveled the longest, between 30 and 40 miles, all three visited on the weekend. I didn't notice any pattern in the 7 people who had the shorter travel to the store, with those people visiting all across the week. This might suggest if you're going to run a sale or promotional event, putting it on the weekend could appeal to all of your customers. Customer satisfaction and subscriptions. 60%, 6 out of the 10 customers said they were satisfied. And of those 6 customers, 5 out of 6, or 83%, subscribed to the newsletter. One curious piece of data, 4 of the 10 people surveyed did not have a smartphone. I suspect this was a possible error in encoding or a potential response bias, in that the people might not want or might not have admitted to having a smartphone, or didn't want to give over their cell phone number, or potentially these are the people who didn't download the app So I'd go back to the original data set and take a closer look at what question was asked that led to this piece of data, because I find it curious that 40% of these young professionals wouldn't have a smartphone in 2023. Some potential areas for further study based on this data set. The out of town, the people who drove the long distance to the store, are they all coming from the same nearby town, which could potentially lead for opportunities to open a second store? And a concern and place for further study, 40% of the customers were not satisfied. I'd like to dig deeper on future surveys or research to figure out why 40% of the customers are not satisfied. Those were my conclusions on what we could conclude from the data, as well as practicing measures of central tendency, measures of dispersion, and measures of position. Uh, Thanks for watching.